Hello and welcome to another video. In today's episode we are going to take a look at the next step in the Arch Linux installation, which is partitioning the disks and creating the file systems. So if you have not yet done so, subscribe to this channel so you will be notified when the next episode for the Arch Linux installation and other computer and Linux related videos come out. So in today's episode we are taking a look at the first step in our installation procedure, which will modify your system permanently and substantially. So in the last episode we updated the system clock. That's some change to your system because your clock will be updated if it was not accurate enough. But now we will be changing the things that are on your hard disks. So be prepared, and maybe you want to try yourself out first in a virtual machine before you go and partition your live system, your own computer. So of course we are following the official Arch Linux installation guide in this tutorial, or what I more like to think about this as an educational video. This is not just we're not just telling you what commands you should type in to install your system. We are trying to explore what those commands do so you understand what you are doing, and you can change these things up. You can modify the installation method that suits your needs and your system the best. So of course when you are installing you should always follow this installation guide, because if anything changes in the official method, this is the place where those things will appear, and if you run into any troubles you will have to reference this guide when you are asking for help on the Arch Linux forums. So here in the contents we can see that the next step we are going to do, the partition of disk, is a very short description of course here, but we are going to take a look at the partitioning itself. What does it entail? So what exactly is partitioning and how does it work? So you in your computer have these permanent storage devices like your hard disk drives and your solid state drives, which contain the data for permanently, which means that the data stays there even after you turn off your computer. So these devices are storing the programs, the program files, and your personal files, and it is possible to create volumes on this disk, which is basically a subdivision of this storage for different purposes. And we have two standards for this, and one is the old standard with this master boot record style subdivision of the disk, and there is the new standard for the universal extendable firmware interface, which is the GPT. And this GPT is basically like the acronym for GUID partition table, and GUID is the acronym for globally unique identifier. So on Wikipedia there is actually a very good and concise description of disk partitioning, so you can reference this if you are interested in how these things are done. For example, in this old standard there are the primary partitions. You can have either 4 primary partitions or 3 primary partitions and an extended partition, and the extended partition can contain more logical partitions. So this is the system that was universally understood by the old computers with the BIOS systems usually, because so this has to be standardized. So the way you store data on your disks, like in the files, like what kind of file system you use, that can be dependent on your operating system, and it is dependent. So each operating system has a different, like a preferred style of storing files in a disk, but the partitioning should be understood by the computer itself. So this should be standardized. It should be independent of the operating system that is running on the computer. And so the GUID partition table is a kind of a newer standard that is used. This is part of this unified extensible firmware interface standard, which is basically the replacement for these PC BIOS systems, and this has like a very complicated layout, so you can just read this Wikipedia article if you are interested in the details. You don't really need to know all that much about it, but so you should know that this standard is kind of the new standard, and if you have any new computers, I know a lot of people hate this UEFI standard and prefer to use the BIOS, but so my suggestion is that just go with the flow and use the newer standard. That's basically what I want to say. So next is going to be, we are taking a look at our virtual machine. I already booted up this virtual machine, and so I had some trouble in the latest episodes. I think the font is too small for you to read if you are watching it on your small form factor smartphone, for example. So I just downloaded some bigger fonts and changed it in this virtual machine, so hopefully you can see what's going on better. So we can check for what disks are available in our machine with either the lsblk command, which will list these things out. So you can see the FD0, which should be like a floppy disk drive. So this is a virtual machine. I don't actually have a floppy disk drive, but since like QEMU has a emulated floppy disk drive anyways. And then loop 0 is basically the Arch ISO virtual file system that I think it's in memory, so it's a RAM disk. SD is like the solid state drives, and the hard drives are appearing in this SD and another letter format. So SDA and SDB is going to be the two virtual hard drives in this virtual machine. Of course, in your real computer, these will be your real hard drives, and SR0 is a CD-ROM. So this is of course, virtual machine, so the ISO is directly mounted. But if you would burn this to a CD and put it in your real computer, this is how it would appear there. So we can also use another tool, which is the fdisk-l. So the fdisk utility has this L command. This gives you a little more detail on what actually is going on these drives. Like disk model is QEMU hard disk, you can see, and sector sizes. So these are more technical details about these disks that you might not be really interested in. So once we checked out what are the labels for our disks, so these are, like you can see, like SDX and NVMe 0 and 1 or something like that can be. So in the next step we can just start thinking about how we want to partition our drives. So if you, of course, maybe your system is already partitioned perfectly because you are switching to Arch Linux from another Linux system, and you already have like a preferred partitioning scheme and everything is ready. You just need to like delete the old Linux system. But maybe you have Windows and you want to delete everything and start from scratch. So I already have a video up where I'm talking about partitioning schemes, especially if you need a separate partition for your home directories or not. But so let's just go through some simple schemes here. So this one is like there is just one big partition on this disk, which is for the root file system. So every file on this computer will be stored on this partition, and there is this swap. So the swap space is basically if your RAM, your memory is full because you open too many Firefox tabs, and each Firefox tab is loading like videos in it, and your memory is just full, then this swap space will be used to kind of extend the memory capacity. So this is of course much slower than your RAM, so your computer will become extremely slow when it starts swapping. And a lot of people will tell you that if you have like a solid state drive, don't use the swap, because swapping will kill your drive really fast. And there are also some people who say that modern solid-state drives are much more sturdy, so it doesn't matter. And anyways, you will probably not open that many Firefox tabs that you will need the swap too often if you have enough RAM in your system. So the second partitioning scheme will have a separate partition for the home directory. This is good if you want to be able to just remove all your system components, but always keep the user files separately. So you can, if your system is borged, you can just format the root partition, and you will, all your personal settings and personal files will be intact. Of course, you should always have backups for that purpose. So that's why I don't have a separate home partition, because every personal file is backed up anyways. So if I have to nuke the system, I can just nuke the system with no problem. Of course, there is another thing here, this boot partition. So boot partition can be sometimes useful. For example, if you want to encrypt your whole hard drive, every program should be encrypted. Your bootloader will have to be placed somewhere where, and so there's some initial files for booting up your system. For example, the programs that can unlock the encrypted drive should be placed in a partition which is not encrypted, so the system can access it, and then this program can load to decrypt the drive and then load your system up. Just very simple, in very simple terms. That's why you can use this. And of course, if you are using the UEFI system, then you will probably, doesn't matter like what kind of partitioning scheme you use, you will have to have like a UEFI, like an EFI system partition, which can be the same as the boot partition actually. And this is how I did it. And so that's usually, if you decide to do a separate boot partition, you don't have to think about the ESP separately. But if you don't want to do a separate boot partition, then you have to think about that. And of course, this is also in the Arch Wiki. There is a separate article called EFI system partition, and this will tell you exactly how you should be using the EFI system partition. So in today's tutorial, we will be using a boot partition, specifically like this way. So this is, this is same way as I set up my own computer, and this is how we will set up this emulated, this virtual machine. So I have a boot partition for the purpose of also containing the EFI stuff that will be needed, and we won't have a separate partition for home, but I have a second disk. So in my actual computer I have a solid state drive for my system files because that's fast, and also I have an HDD for my personal file because HDDs are much more cheap when you are going to like the terabyte range. And so here we will have like a media/data point where we can just have, it's kind of like an external data storage. Then you can just link the files from here to your home directory. And we will also have some space for another operating system for dual booting in the future. So how can we do this? So we have several partitioning tools available for us on the Arch Linux ISO. Fdisk and Gdisk are basically, so Fdisk is this very first kind of the base utility, which is a command line utility and is good for master boot record and GUID partition table case also. But Gdisk is kind of a better, newer version which only has GPT. So CFdisk and CGdisk are two pseudo-graphical tools for partitioning, which means that they have this kind of character-driven graphical interface. So we will be looking at CG disk. In our virtual machine, we will start with the SDA partition there. So let's just type in CG disk /dev/SDA, and you can see that this program detected that this is a non-GPT disk, because so this is a totally empty and new virtual disk. Of course, if you have already had a Windows installation that you want to override, then this will just list all the partitions for you. But if you have a very new disk, then this is what you will get. First, it will have to create the GPT headers and all the special tables for the GPT standard to work on your disk, and then you just press the spacebar and you are here in this list. So this is only free space. If you have partitions, you can navigate between them with the up and down keys, and at the bottom you can see this menu. This is left and right, and also each word has one letter with the capital letter, and you can just type or just press that key on your keyboard and your menu point will be selected. So we created the GPT table, so we will be creating an EFI system partition. So I have the steps written down here. So how does it look like in the program? So we selected the new, which is a create new partition from free space, so just press enter. And first sector, we can use the default one because we just want this this partition to start from the beginning of the disk, and we can type a size in sectors, so you can just type a number which will be sectors, or you can type in the size with kilo, mega, giga, tera, or petabytes. And so in this case we will create a 400 megabyte system EFI system partition for our boot partition. And so here we will need a hex code for GUID. So GUID. So this is going to be the identifier of what type is this partition going to be. And so we don't know, so we can just press the letter L and press enter, and we can type in, we want to have the system partition, so EFI system partition, so I just type in EFI with all capital letters because this is an acronym. And here now you can see that the EF00 is EFI system, so just press enter and press EF00 and press another enter. You can give a name. I just give it, let's give it ESP, and you can see now the ESP named EFI system partition appeared here, so we can just use the up and down arrow keys to navigate, and we will create another new partition there, which will be our root partition. So I just press enter because I want the beginning of this free space. I press another enter because I just want this to take up the whole remaining space. And so this is going to be a Linux partition, and in this case the hex code is 8300, and this is the default value, so I can just press enter again, and I just give it a name root and press enter. Then you can see this appeared here. So whatever you did up until this point, this is only in memory, so nothing has been written to your disk right now. So if you just go to quit, then your disk will be unchanged. So maybe you just realize that you screwed this up royally, so you just want to start again, so you can quit and start again. But we will write the partition table to the disk. And so this may destroy your data. So if you have any data on your disk, this is the time to change your mind, maybe. If not, you have to type in yes, like Y, E, and S, and hit enter. And operation has been completed successfully, so now you can quit. And let's lsblk-f, let's just lsblk. You can see now we have SDA1 and SDA2 created there, and if we say lsblk-f, that will give us some. We don't need that yet. This is the info we can get now. So let's see. So we created the EFI system partition, like the boot partition, and we also created a root partition for Linux file system. And so let's create a swap on the second disk. So we will also create a new GPT table, and we'll create the swap partition. And let's take a look at how does that look like. So cd disk /dev/sdb, and of course this is also a new disk, so let's just press enter here. First sector. Okay, so I will just give this 5 gigabytes of swap space because this virtual machine has 4 gigabytes of memory to it, and usually you should give it equal swap space plus a little. So if you want to hibernate your system to the disk, then all the contents of the memory can be written to the swap partition. And then we want to find the swap. So we'll just hit letter L, enter, and type in swap and hit enter. You can see there are 5 different kind of swap partitions. We need Linux swap, which is 8200. So let's just type 8200 plus enter. We can just name it swap. And so the remaining free space, I will deal with that later. This is going just for you. I just write the swap to the disk. Press yes, type yes, enter yes, type or press enter, and operation completed successfully. So let's quit, and let's lsblk again. So now we can see that we have SDA1, SDA2, and now we have also SDB1. So next thing is going to be creating file systems. So what is a file system? So we already have partitioned the disk. So the disks have these sections where we can store data. But well, how do we store data on a disk? So a disk is like a lot of bytes can be put on a disk, but we need to organize these bytes into files for us to be like worth anything. And this is done by the different file systems. So different file system has different method of storing, like they need to store what file is on the disk and then where exactly the contents of the file is stored on the disk. And this can be done a lot of different ways. Like Windows has its own file system, the NTFS file system. There is the old DOS file system, which is a FAT, file allocation table, FAT. Linux systems usually use ext4, but there is also a lot of different file systems for like servers where the file system takes care of keeping older versions of the file. So if you modify a file, it's actually not getting overwritten, but it's got copied and then changed, so you can roll back file versions, etc. So we usually, I think, as a newbie, especially using ext4 extended for your Linux partition is going to be good. So we can make this file system on our disk by using the mkfs.ext4 command and we can type in /dev/sda2. This is, sda2, so this is the 9.6 gigabyte root partition we made. So this will write all the information on the disk that the system will need to identify where the files should be put, etc. And of course, so I already made some video about installing a system which can be run from a USB drive. So ext4 in general is a journaling file system, which means that basically a lot of information is just written first at like a journal space on the disk, and then once everything is written at the journal, then this file will be written at its final location. And so this way, if writing gets interrupted because, for example, the power goes off and your computer dies, then this either can be restored from the journal, or if it was interrupted when it was being written to the journal, then the actual file will be undamaged, but of course in the original version. So this is actually very heavy on like new writes on your disk. So if you have like a cheap USB drive, you install a system like on a bootable USB key, maybe you want to add this option to, so you don't have a journal there, and will increase the lifetime of your USB device. So if you need to also format the ESP partition. So let's do that. The ESP partition will be partitioned for a FAT format. So this is the old FAT file allocation table format, which is a very primitive way of storing data on a disk, but it is also very easily implemented. So the computer, the EFI chip, will be able to read your bootloader and execute it from there. So let's press enter, and it's already created it. Nice. We can then turn on the swap with the swap on command, and we created the swap partition on SDB1. So let's do that. What? Swap header failed. Oh, so what happened is I actually forgot to make the swap and then turn on the swap according to the Arch wiki. So this is why you always follow the Arch install guide and not some random guy's tutorial on the internet. So mkswap /dev/sdb1 and then swap on the same SDB1. So now the swap is also turned on. Okay, so now we've done that. So we can also, if you want to have, like, if you are creating a USB drive, then you can create an ExFAT partition, or maybe you have a system where you dual boot and you use also Linux and Windows, or Linux and Mac OS, and you want to have a partition where you can put data files that can be read by all operating systems. This is usually the ExFAT is kind of the best choice for that, because ExFAT allows you to have extra large files, and also all operating system can handle it properly. So you can also try NTFS if you only have Linux and Windows, but sometimes the NTFS partition gets screwed up if you are using it mostly from Linux and you don't use it with Windows. So that's why the ExFAT is probably the best choice to have this kind of exchange place for data between different operating systems. Okay, so this was the end of this presentation. So now you know how to partition your disk, or at least what is the process of partitioning your disk, and now you can figure out how you want to do it on your computer. and what kind of file systems you should use and how can you create those file systems on your device. So I think if you have any ideas of how to partition, what kind of partitioning scheme to use on your computer, then you can just share it in the comments and we can discuss about whether that makes sense or not. Like, for example, you can argue with me about having a home partition for the user files or just throw everything on the same partition. We can argue about that. And so if you enjoyed this video, if you found it useful, then why don't you give me a like? And if you would like to get up to date with content I put on this channel, which is mostly concerning Linux and open source computing, but not exclusively that content, you can subscribe somewhere here, and you can check out my playlist for the Arch Linux stuff, and I'll see you in the next episode. Bye bye.